To estimate the new total load, multiply the highest current draw by 2. In this case, it's 34.3 amps times 2, which equals 68.6 amps. If the main breaker is double lugged and the subpanels are in parallel, then they are essentially operating as one panel. The main breaker provides overcurrent protection for the entire system. The National Electrical Code, or NEC, does not specify a limit on the number of subpanels that can be fed from a main panel board. However, it does require that each subpanel be protected by a circuit breaker or fuse, and that the total load on the subpanels does not exceed the rating of the main breaker. To ensure a properly sized electrical system, consider the following steps. Firstly, confirm the paralleled configuration. Verify that the subpanels are indeed in parallel by examining the wiring diagram or consulting with an electrician. Secondly, estimate the future load. Account for any additional loads that may be added in the future, such as new equipment or expansion. Thirdly, consider surge protectors, as computer loads can be sensitive to voltage fluctuations and surge protectors can help protect against damage. And fourthly, consult an electrician, because an experienced electrician can assist with load calculations, panel selection, and wiring. The NEC does not have a specific article regarding the number of subpanels that can be fed from a main panel board. However, Article 240 addresses overcurrent protection and Article 310 covers feeders for subpanels. It is important to ensure that the electrical system is safe and compliant with all applicable codes and regulations. Overcurrent protection is a critical aspect of electrical safety. It protects the electrical system from damage caused by excessive current flow, which can result from overloads, short circuits, or ground faults. Circuit breakers and fuses are the two most common types of overcurrent protection devices. A circuit breaker is a reusable device that automatically interrupts the flow of current when an overload or short circuit occurs. Fuses are one-time devices that melt and break the circuit when subjected to excessive current. Article 240 of the NEC provides detailed requirements for overcurrent protection. It specifies the types of overcurrent protection devices that are permitted, the ratings of these devices, and the locations where they must be installed. Proper feeder sizing is essential for ensuring that subpanels receive an adequate supply of power. Feeders are the conductors that connect the main panel board to the subpanels. The size of the feeders must be sufficient to carry the total load of the subpanels they serve. Article 310 of the NEC provides guidelines for sizing feeders. It includes tables that specify the allowable ampacities of different types of conductors based on their size, insulation, and installation conditions. When determining the appropriate size of feeders, it is important to consider the following factors. Firstly, the total load of the subpanels. Secondly, the voltage drop in the feeders. And thirdly, the ambient temperature. Voltage drop refers to the decrease in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to a maximum of 3% for feeders. Ambient temperature can also affect the ampacity of conductors. Higher ambient temperatures reduce the ability of conductors to dissipate heat, which can lead to overheating and premature failure. The NEC provides correction factors that must be applied to the ampacity of conductors when they are installed in high ambient temperatures. When installing subpanels, it is essential to follow all applicable NEC requirements. This includes ensuring that the subpanels are properly grounded, that all connections are tight and secure, and that the subpanels are adequately ventilated. Grounding is a critical safety measure that helps to protect against electric shock. It provides a low-resistance path for fault current to flow back to the source, which causes the overcurrent protection device to trip and to energize the circuit. The NEC requires that all subpanels be grounded to a common grounding electrode system. Proper ventilation is also essential for preventing overheating of the subpanels. Subpanels should be installed in locations where there is adequate airflow to dissipate heat. The NEC specifies minimum clearances around subpanels to ensure proper ventilation. In addition to following NEC requirements, it is also important to consider local codes and regulations. Local codes may have additional requirements that are not covered by the NEC. It is always a good idea to consult with a qualified electrician to ensure that the electrical system is safe and compliant with all applicable codes and regulations. Surge protection is an important consideration for computer loads, as they are particularly sensitive to voltage fluctuations. Surges can damage or destroy sensitive electronic components, leading to data loss, equipment failure, and costly repairs. Surge protectors work by diverting excess voltage away from sensitive equipment. They contain components that clamp down on voltage spikes, preventing them from reaching the connected devices. There are two main types of surge protectors: firstly, point-of-use surge protectors, and secondly, whole-house surge protectors. Point-of-use surge protectors are typically plugged into a wall outlet and provide surge protection for equipment connected to that outlet. Whole-house surge protectors are installed at the main panel board and provide surge protection for the entire electrical system. When selecting a surge protector, it is important to consider the following factors: firstly, the surge current rating, and secondly, the clamping voltage. The surge current rating indicates the maximum amount of current that the surge protector can withstand. The clamping voltage is the voltage at which the surge protector begins to divert excess voltage. A lower clamping voltage provides better protection. It is also important to choose a surge protector that is listed by a recognized testing laboratory, such as Underwriters Laboratories or UL. UL listing indicates that the surge protector has been tested and meets certain safety standards. In addition to surge protection, it is also important to consider other power quality issues such as voltage sags, voltage swells, and harmonic distortion. Voltage sags are temporary decreases in voltage, while voltage swells are temporary increases in voltage. Harmonic distortion is the presence of unwanted frequencies in the electrical system. These power quality issues can also damage or disrupt the operation of sensitive electronic equipment. Power conditioners can be used to mitigate these power quality issues. Power conditioners regulate voltage and filter out unwanted frequencies, providing a clean and stable power supply for sensitive equipment. When planning an industrial renovation, it is important to carefully consider the electrical system. The electrical system must be adequately sized to handle the increased load, and it must be safe and compliant with all applicable codes and regulations. Consulting with a qualified electrician is essential for ensuring that the electrical system is properly designed and installed. Doubling the load on an existing electrical system requires a thorough assessment and careful planning. It's not just about multiplying the highest current draw, but also about understanding the system's configuration, potential future loads, and safety considerations. Let's break down the key aspects to ensure a safe and compliant upgrade. Firstly, confirm the panel configuration. The statement about the main breaker being double lugged and the subpanels being in parallel needs careful verification. Double lugging, which means connecting two conductors to a single lug, is generally not permitted by the NEC unless the lug is specifically designed and listed for that purpose. If the panels are indeed wired in parallel, it means the current is split between the subpanels. This arrangement is acceptable, but it requires careful consideration of conductor sizing and overcurrent protection to ensure each panel receives the correct amount of current and is protected from overloads. Consult an electrician to inspect the wiring and confirm the configuration. They can determine if the double lugging is code compliant and if the parallel wiring is properly executed. Secondly, accurately estimate the future load. Multiplying the highest current draw by 2 provides a rough estimate, but a more detailed load calculation is crucial. Computer loads, while seemingly small, can contribute significantly to the overall load. Consider the following factors for each piece of equipment. Firstly, the nameplate amperage. This is the maximum current the equipment is designed to draw. Secondly, the duty cycle. This is the percentage of time the equipment will be operating at its maximum load. Thirdly, the power factor. This is a measure of how efficiently the equipment uses electricity. Multiply the nameplate amperage by the duty cycle and the power factor to get a more accurate estimate of the actual current draw. Add up the current draws of all the new equipment to determine the total additional load. Don't forget to account for any existing equipment that will be used in conjunction with the new equipment. Add the additional load to the existing load to get the total estimated load. It's always a good idea to add a safety margin of 20% to the total estimated load to account for unforeseen increases in demand. The NEC provides detailed guidelines for load calculations in Article 220. This article covers various types of loads, including general lighting, receptacle outlets, appliances, and motors. It also provides factors for demand and diversity which allow you to reduce the calculated load based on the likelihood that not all equipment will be operating at its maximum load simultaneously. Thirdly, ensure adequate overcurrent protection. The main breaker must be sized to protect the entire electrical system from overloads. The NEC requires that the main breaker be sized no larger than the ampacity of the conductors feeding the panel. The ampacity of the conductors is determined by their size, insulation type, and installation method. Use NEC Table 310.16 to determine the ampacity of the conductors. The subpanels must also be protected by circuit breakers or fuses. The size of the subpanel breakers must be sized to protect the conductors feeding the subpanels and the equipment connected to them. The NEC provides guidelines for selecting the appropriate size of overcurrent protection devices in Article 240. Fourthly, consider voltage drop. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to a maximum of 3% for feeders and 5% for branch circuits. Voltage drop is affected by the length and size of the conductors, as well as the current flowing through them. Use a voltage drop calculator to determine the voltage drop in the conductors. If the voltage drop is excessive, you may need to increase the size of the conductors. Fifthly, address grounding and bonding. Proper grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which causes the overcurrent protection device to trip and energize the circuit. Bonding connects all metal parts of the electrical system together, creating a low impedance path for fault current. The NEC provides detailed requirements for grounding and bonding in Article 250. Ensure that all subpanels are properly grounded to a common grounding electrode system. Bond all metal parts of the electrical system together, including conduit, enclosures, and equipment. Sixthly, address surge protection. Computer loads are particularly sensitive to voltage surges. Surge protectors can help protect against damage from surges caused by lightning, utility switching, or internal electrical events. Install surge protectors at the main panel board and at each subpanel. Choose surge protectors with a high surge current rating and a low clamping voltage. Seventhly, consider the number of subpanels. While the NEC does not specify a limit on the number of subpanels, it's important to consider the overall complexity and manageability of the electrical system. Too many subpanels can make it difficult to troubleshoot problems and can increase the risk of errors during maintenance or modifications. A well-designed electrical system should have a logical layout and be easy to understand. Eighthly, comply with all applicable codes and regulations. The NEC is the primary electrical code in the United States, but local codes may also apply. Local codes may have additional requirements that are not covered by the NEC. Consult with a qualified electrician to ensure that the electrical system is compliant with all applicable codes and regulations. Finally, document everything. Keep detailed records of all load calculations, wiring diagrams, and equipment specifications. This documentation will be helpful for future maintenance, modifications, and troubleshooting. By following these steps, one can ensure that the electrical system is adequately sized, safe, and compliant with all applicable codes and regulations. Remember, working with electricity can be dangerous. If not comfortable performing any of these tasks, consult with a qualified electrician.